Good morning, everybody. Today is May 11th, and this is your math lesson for today. We're going to learn about multiplying mixed numbers by whole numbers. All right, and this again is just a quick anchor chart for you about multiplying a fraction and a whole number. It shows you how multiplying a fraction times a whole number is the same thing as repeated addition. There's an example here on the number line of how you're jumping 2/3 and you get to the whole. And then on number 3 shows you the model of adding it together and how it equals 2 wholes. Right? So 3 times 2/3 is the same thing as saying 2/3 added together 3 times, which gives you 6/3, and that 6/3 turns into the number 2. All right, so I can use patterns and equations to multiply a fraction by a whole number. With multiplication, we need to remember that the associative property of multiplication says that it doesn't matter the order of the numbers that you add, that it always comes out to the same product. So whether you multiply 5 times 4 first, or you multiply 4 times 2 first, okay, it shows you 5 times 4 is 20. Then I take that 20 and I multiply it by 2, okay? And 20 times 2 gives me my product of 40. Then I have 5 times 4 times 2 again, but first I did 4 times 2, and 4 times 2 gives me 8, and I take that 8 and I multiply it by my 5, and you can see again it comes out to 40. All right, so how does that apply to fractions? So here we're going to just quickly go over again mixed numbers turning into improper fractions. So if I have 4 2/3, a mixed number is a whole number mixed with a fraction. So 4 2/3, and I want to turn it into an improper fraction. So what I do first is step 1, multiply the whole number times the denominator. And you can see here that I got 12. 4 times 3 is 12. Step 2 is add the product of the whole number in the denominator and add it to the numerator. So 12 plus 2 gives me 14. Then I take that 14 and I put it back over my denominator, which is 3, and my improper fraction becomes 14/3. But what if I started with an improper fraction first and I needed to make it into a mixed number? Okay, this line here that splits your numerator and denominator means the words divided by. Okay, so really what this fraction says, 14 divided by 3. 3 is my divisor and 14 is my dividend. Okay, so I come over here, and really what they did was they kind of just made a house and brought the 14 underneath. Okay, so they said 14 divided by 3 equals, well, how many times does 3 go into 14? 4 times. So 4. So first we must divide, then we multiply. So 4 times 3 is 12. Then we subtract. 14 minus 12 equals 2. And because that's my remainder, in the past we've done R2 for remainder 2. But to make a mixed number, really what we do is we take that remainder, which is your R, remainder 2, and we put it over the divisor. And that's how I get a fraction. So it's 4 2/3. Instead of 4 remainder 2, it becomes 4 2/3. So we're going to go ahead and try it. So I have this fraction here, and it says 3 4/5. Step 1, multiply your whole number times your denominator. And you can see I have 3 times 5, which equals 15. Step 2, right, so that's multiply. Step 2 is take your product and add it to the numerator, which means, right, I said result, but really it's product. Okay, so add your product to your numerator. So 15 plus 4, which gives me 19. Take that 19, which is your total result, and you're putting it back over your original denominator. So now I've just made an improper fraction of 19 fifths. But what if I had 32 fifths to start, right? Sorry about that. So remember, this line means divided by. So what I do here is I take this and I make a house and I bring my 32, right? And I take this away over here. So now I have 32 divided by 5. How many times does 5 go into 32? Well, if you know your multiplication facts, you know that 5 goes into 32 6 times. So 6 times 5 equals 30. And I subtract 32 minus 30. I have 2 left over. And then I take that 2 and I put it over my original denominator. So 32 fifths is actually equivalent or equal to 6 and 2 fifths. You're saying, Mrs. DiMiola, what does this have to do with multiplying? All right, so we're going to go ahead and we're going to check this out. A recipe for 1 gallon of fruit punch calls for 3/4 cup of orange juice. How many cups of orange juice are needed to make 8 gallons of fruit punch? Solve this problem any way you choose. So now we're not in school, so we're going to go ahead and we're going to try this together. All right, so if I have 8 gallons, I need to make 8 gallons, but each gallon takes 3/4. So that's like saying, okay, well, 1 gallon is 3/4. Then I need another gallon that has 3/4. So I'm actually adding 3/4 8 times, right? 1, 2, 3, 4, 5, 6, 7, 8. All right, so I've added it 8 times. Really, that's the same thing as saying 8 times 3/4. Okay, and how do I do that? Well, 8 times 3/4, I go ahead and I multiply my numerator times my whole, and 8 times 3 is 24. And I put it back over 4, and I get 24/4. But now this is where I have to divide, right? 24 divided by 4. Well, I know that 4 goes into 24 6 times. So that means that 6 cups are needed to make 8 gallons. Okay? 6 cups of orange juice are needed to make 8 gallons of fruit punch. So let's go ahead and watch this video. I'm going to take my pen off. Whoops. Sorry, guys. All right, so let's go ahead. Back through, sorry. And we're going to play the video. I forgot to log in. I'm sure this happens to you guys, so make sure you stop and you log into your Envisions. So I'm going to do that really quick so we can play the video together. All right. Close that out, go back to my PowerPoint, and click the link.
When can you use the product of a fraction and a whole number to solve a problem? Think about this question during the lesson. Stanley makes ice cream sundaes. Today, Stanley made 2 ice cream sundaes. How much ice cream did Stanley use? Find 2 times 3/4.
All right, so
Stanley made 2 sundaes. How much ice cream did he use to make each sundae?
we need to
He
know
used
how much.
3/4 pint in each sundae.
This has 3/4.
You need to find how
this
much
has
ice cream
3/4.
Stanley used. What units will you use for the solution? Use pints for the solution. You can use structure when multiplying a fraction and a whole number. Here is one way to solve the problem. 3/4 is 3 copies of 1/4. How can you write 3 copies of 1/4 using multiplication? Select your answer.
So 3 copies of 1/4 is like saying 1/4 plus 1/4 plus 1/4, or originally 3 times 1/4.
You can write 3 times 1/4. What does the associative property of multiplication allow you to do?
So remember at the beginning, the associative property, we said you can multiply any of the numbers in order, right? So really what happens is the associative property says, well, we can multiply 3 times 1/4 and we get 3/4, and then we take 3/4 times 2. Or what we can do is, I lost my pencil here. You can take 2 times 3 and you get 6. And then 6 times 1/4 would give you 6/4.
It allows you to change the grouping when multiplying numbers together. So you can write 2 times open parenthesis 3 times 1/4 close parenthesis as open parenthesis 2 times 3 close parenthesis times 1/4. 2 times 3 equals 6. Now multiply the whole number and the numerator. 6 times 1 equals 6. 2 times 3/4 equals 6/4, which is 4/4 plus 2/4, or 1 2/4. Here is another way to solve the problem. Multiply the whole number and the numerator. Why can you multiply the whole number 2 by the numerator 3? There are 2 groups with 3 1/4 in each group. How can you write 2 groups of 3 of something using multiplication?
How can you write 2 groups of 3 of something using multiplication? Think about that question.
You can write 2 groups of 3 as 2 times 3. So there are 2 times 3 equals 6 1/4 in all. 2 times 3/4 equals 6/4, or 1 2/4.
So how they got that 1 2/4 is because 6 divided by 4. 4 goes into 6 one time, and there's 2 left over, and that 2 that are remainder goes back over that denominator.
Stanley used 1 2/4 pints of ice cream to make 2 sundaes. Now you know how to use the product of a fraction and a whole number to solve a problem.
Here's a challenge question. 1 2/4, what is that also equivalent to? Think about it. 1 2/4. What is that equivalent to? If you guessed 1 1/2, you were correct, because 2/4 can be lowered down to 1/2 because 2 is half of 4. All right. So now let's think about this. All right, let's do the convince me. So it says use properties of operations to calculate 3 times 3/6. Show your work. All right, so 3 times 3/6 is the same thing as saying 3 times 3 times 1/6, because 3/6 is 1/6 repeated 3 times, right? It's 3 copies of 1/6. So really what they did was they put this 3, 6 that they started with right here, and they did expanded form, okay? And they broke it down into this, 3 times 1/6. So now I'm going to take it and I'm going to use the associative property, and I'm going to switch the parentheses, and I'm going to put it around 3 times 3. And 3 times 3 gives me, if you said 9, you were correct, times 1/6. Now, see, I wrote that and I popped it up. Now, 9 times 1/6 gives me 9/6. And then I do my division. 9 divided by 6. So 9 divided by 6, 6 goes into 9 once. I have 3 left over, and I put that 3 back over the original denominator. Okay? And I get 1 3/6. Now, challenge, 1 3/6, what does it equal? If you said 1 1/2, you were correct, because 1 3/6 can be reduced or lowered down to 1/2. Challenge question. Good job. All right, so let's practice. I have here 3 of the same copy, right? 3 times 8/9. So 3 times 8/9 is the same thing as saying 3 times 8 times 1/9. And I take that 3 times 8 and I do it first, and I get 24. And 24 times 1/9 gives me 24/9, which then turns into 2 6/9. All right, so let's try it over here. So I have 1, 2, 3, 4, 5, 6 times, and what's each box? 1/4. So 6 times 1/4 gives me 6/4. And remember, divided by, so 6 divided by 4, how many times does 4 go into 6? Once. What's left over? 2/4. Really what happens is if I take this box here, I'm going to color it in. Then I'm going to take this box here and I'm going to color it in. Then I'm going to take this box here and I'm going to color it in. And you can see now I made a hole, and I have 1, 2 left over. All right, so I have 1, 2, 3 copies of 2/3. 3 times 2/3. But really, what I can do here is 3 times 2/3. And that gives me 6/3. Then 6 divided by 2, how many times does 3 go into 2? Well, that's even 2 holes. Then I have 1, 2, 3, 4, 5, 6, 7 copies of 1/2. So 7 times 1 gives you 7 over my original denominator, which is 2. How many times does 2 go into 7? Because it's 7 divided by 2. Well, it goes in there 3 times with 1 left over, and I put my 1 over my original fraction. Okay? So you guys are going to try this out on your own. All right? So make sure you're using the associative property. You'll fill these 5 in. And then you'll go to the homework buddy and you'll complete the homework buddy, do some reflex today till your green light, and then you will work on iExcel diagnostic for about 10 minutes. If you're pinpointed, then work on a couple of recommendations. And that's it for today, guys. All right. Hope you enjoy your day. And that's all.